Hello, it's Chris Delion again. This is the next video in the series for introduction to sort of interactive graphical programming. I'm a TA for LMC 6310, the Computers and Expressive Medium course at Georgia Tech, taught by Dr. Jay Bolter. In previous videos, we've shown some operations like drawing basic shapes to the screen, some basic programming structures. More recently, we had balls of different sizes bouncing all over the screen. If those sound like things you'd like to learn how to do using array lists and forming a basic class, I encourage you to check out the earlier videos in this series to help build up to where we're at today. Those are things I'm going to be kind of assuming you already know. We're going to be starting from scratch on a blank file, but I'm going to rush over some of those details under the assumption that you've followed the previous videos. And part of the benefit of the videos, of course, I can send you back there. You can pause me, stop me, rewind me. I know I can talk a little fast sometimes. I really get passionate about programming. I'm just trying to help out, but the videos hopefully help you navigate around my tendency to get too excited about what I'm trying to share. So this time we're going to be covering some more niceties of processing. So previously, we've always shown that when you start your program, you should have a void setup and a void draw. Setup will be called once when the program starts. Draw will be called continuously, every single frame, about 30 times or so per second. In setup, we always want to set size, which I think this is the size we figured out works nicely under my video here on the screen. Yeah, that'll fit snugly. That'll fit nicely, so we can have both on the screen in tandem. Okay, and like we've shown before, if we want to have something that draws sort of a smudge around the screen, so let's have an ellipse. Remember that an ellipse takes a center coordinate, which are going to give it mouse x and mouse y, those being values that automatically get overloaded by processing every frame to the last position of the mouse at the time of the frame. And then a width and a height for the ellipse. The ellipse is by default center point drawn, so this acts as the center. And the width and the height, effectively diameters, on an ellipse, if you make them the same, form a circle. So we now have a circle that we can drag around. And this is kind of a nifty smearing effect, since we're not yet using a background call to wipe the screen each time. And the downside to that is we can't actually dynamically deal with those data points. So if we wanted to have this snake kind of like jitter and move on its own, which could be kind of a neat effect too, right? We can't right now because those are just pixels that have been plotted down and never erased. We don't actually have stored in memory in any way a trail for where this mouse has been. And that could be a really powerful thing to do. So if you want to make a vector-based drawing application, you could then zoom in on. If you want to make it so the lines grow frost or catch on fire, maybe something chases down the lines or it uses them as wall data or something, it's useful to be able to store those points in an array list, just like we did with the balls in the previous one. So let's go and review how we would do that. Remember that in the previous one, when we wanted to store multiple balls, we created a new class for them. Let's call this one mouse points. I'm going to use capital M. Mouse PT. And now there are built-in structures into processing that we could use, but I think it's going to be helpful practice for us to make our own for keeping track of the mouse locations. The only data storage that I need for that mouse point is an MX and an MY. And what we're going to do is, for the constructor, so when we say new mouse point, it's going to capture as its MX and MY the current mouse position X and Y. We could pass in parameters if we want to customize these somehow, if we make this different than the mouse position. But because we know that each time we create a new mouse point for the trail, we want to save where the mouse X and Y were at the moment that it was created, we can put these in the constructor like this, and it's kind of a little hack that's going to help us do what we want to do with it. So far, that's all we got. And let's also have a void draw PT. And there's various ways we could deal with this. We'll probably actually wind up writing some line drawing code elsewhere. But for now, let's have it draw that ellipse, MX, MY. And as proof to us that we are in fact constantly redrawing these points, that these are not just leftover pixels, let's change the fill color randomly. Random 255, 255, 255. Let's go ahead and save our sketch. Let's say mouse PT, just an example of what to name it. And it's going to be useful actually to save our sketch because we're going to be putting an image into this sketch. And in order to put images or font files or other external types like that into processing, you need to have a data folder. And to add a data folder, you have a sketch folder. To have a sketch folder, you need to have saved your sketch. So I just went to File, Save. I kind of did my Command S shortcut. Control-S on Windows, but you got to save it in order to have the space to put your files as we move towards images and fonts, but kind of in that case, just me being hyperactive. Okay, so we have a way to track a mouse point at the moment of its creation, and we have a function we can call on each individual mouse point we've tracked that'll draw its position with a random color. Now we're going to want an array list. Mouse trail equals new array list. And there's ways to specify the type for the mouse, for the array list, so it knows to only accept mouse points, but this is going to work fine for us for now. Mouse trail. Now for setup, let's just try manually, first of all, adding a couple. Actually, that won't really work well because we are setting it to the mouse position at each. So instead, here in draw, let's say mousetrail.add new mouse point. And actually, let's go one back. Let's say if mouse button. So only while the mouse button is being pressed, then it's going to add a new mouse point. Oh, sorry, straight semicolon. It's going to add a new mouse point into the mouse trail list. And then we're going to have a different part of functionality in the code. Let me give it a little more white space. It's going to do for int I equals 0. I is less than mousetrail.size, I++. We're then going to get mouse pt. Each point equals casting as mouse point, mousetrail.get at I. And this for loop, just to reiterate what we kind of walked through in the previous video about the balls that were bouncing, the type that we need to borrow from that list is a mouse point, because that's the structure. That's how it knows what variables and functions we can ask for from it. It has to, we're getting like the one that corresponds to our index. So here we're looping through. We're starting at 0. We're counting up to, if there's five mouse points stored so far, then it's going to be 0, 1, 2, 3, and 4, one at a time, each loop through that 4. So it's getting I. So first it's getting the 0th, then the 1st, then the 2nd, then the 3rd, and so on. It's casting what comes back out of that as a mouse point, because an array list could have any kind of classes inside it. We just happen to know in our program here that we're only putting mouse points in it. Saving it temporarily as each point allows us then to call methods or adjust values on it. Methods being a Java word for function. And so each point dot drawPoint. DrawPoint is the function we defined in the mouse point tab that's going to randomly pick a color and draw an ellipse at its location where it was saved. And if this worked, oh, so far so good. If mouse button, let's try not equals 0. And see ellipse, float. Okay, of course, ellipse wants a width and a height. By the way, these errors that come back from programming, I don't know if I stressed this enough earlier on in the other ones, because you might have seen I'm very used to writing these kind of introductory programs. Sometimes I get by and don't run into complications. They happen all the time in programming. They're a very normal part of programming. You shouldn't feel like you're doing anything wrong. Expect compiler feedback. Expect to get the little pushback from it. Let's make the circles 20 by 20. That's diameter, not radius. But don't feel bad about it. That's why the compiler is there, to help you catch little issues like that. And now if it worked, when I click and drag, now we get this sweet design. Yeah, there we go. That's pretty exciting. And we could even have those points move. So let's say we have another function we're going to add in mouse point called movePoint. And let's say we just want to make it move around randomly. Plus equals random. Remember, if we give random 2 different numbers, then it's going to give us a random value between them. And now you might be wondering, okay, well, first of all, plus equals, as a reminder, is the same as saying mx equals mx plus random, which is essential because the equal sign in programming assigns value left. So it's substituting in the value that x was. It's adding a random number between -2 and 3 and saving it back into mx, because an equal sign assigns values left in programming. It's not like a balance in algebra. Now, maybe you're wondering, why is it -2 to 3? Random, as a range, is inclusive on one end and exclusive on the other. What that means is, when we say random -2, 3, we can actually get a -2 out of this, but we will never get a 3. The most we would get is like 2.999 whatever, which, because mx is an integer, is going to truncate it. So -2 to 3 as the random range here is actually going to allow us to get -2, -1, 0, 1, or 2, an even balance where it's going to go either 1 or 2, either left or right, or 0, it's going to stay right where it was at. So that's going to give it some random movement. Let me move some things around over here. And we're just going to leave it at that for now. We still have to call this function for it to happen. We could put move point inside draw point, or we can call it separately out here. Let's go and just call it separately out here just to keep a visibility on what we're doing. So for each point, we're going to move the point, and then we're going to draw the point. Press play, and when I draw them, you can see now they're kind of escaping from where they started. And of course, they're leaving all that black muck because they have their stroke on. We can turn off that stroke to get rid of that muck. No stroke. And now we kind of have a prettier pattern. But still, that trail is happening, and it's kind of deceiving, right? Because that's data we don't have access anymore. This is still the same way that in the first place we were just smearing a circle around. It's just because we're not clearing the buffer ever. We really should do that. So let's go ahead and add a line up here. Background 0. Which is essentially identical to telling the program fill color 0, rect 0, 0 with height. It's just drawing a box, the full dimensions of the screen of the color, or the value in this case, the brightness 0. And that's going to keep us a black screen. There we go. And now you get a better sense for exactly what's in the data, exactly what's going on with it. Let's say we wanted to draw a line between those points instead of currently they're sort of all being drawn individually as circles. First off, let's make the circles much smaller. That's going to make it easier for us to see our line as we work on it. And sure enough, theory confirmed. Okay, now let's get to line drawing. Let's white out the background instead of black, so I made this 255 instead of 0. Remember the brightness intensity values for color. Most computer arrangements are 0 to 255. It has to do with the range of an 8-bit integer. Semi-historical reasons for that, but as it works out, 255 is maximum brightness when we only specify one color channel, implying all 3. If we wanted a color, by the way, we could give it 3 different values. So this would be red, full blue, no green. That would be a purple. Bit of a refresher from some of our first videos. But if we give background only a single value, then it assumes we only mean to tell it the brightness value. So there's our background. Now if we want to draw lines between them, then we will need a way to connect each point to the next point. And what I'm first going to suggest we do for that is let's detangle our logic code from our movement code. So I duplicated that code down here. And in one of them I'm going to get rid of move point and one I'm going to draw point. This way we have one pass over all the points that's going to handle the movement, and then another pass that's going to handle all their drawing. For starters, let's go ahead and comment out the movement code altogether so that we're not having to worry about that while we're just getting the lines to draw. Next, we're going to still iterate over the entire list of them to draw each point, but instead of drawing the points here in this fashion, we're going to count one less than the total length of the list. Because what we're going to do is, for each point that we find, we're also going to look at the point one ahead of it and draw a line from us to that one. Because we always are counting on having a point ahead of us, we don't actually want to draw starting from the last point because there's no point ahead of it to reach to unless we want to make a loop, in which case I'll show you how to do that too if we want to have the last point point back to the first point with a line. So let's see, start point, end point. And you see here this +1, which is going to give us the next point in the series. So if start point, because I is 2, then end point would be 3. And this is again why we have to have that -1 here to keep us from falling off the end of the list. And now instead of doing draw point on it, we're instead just going to make a simple line call that's going to directly access startpoint.mx.my. That's our coordinates for start point. Remember that the mx and my came from the fact that those are the names of our values here, public by default in processing, if you know about variable sort of encapsulation and abstraction and whatnot. And then the other part will be endpoint, mx and my. And so it's going to draw a line. Yeah, I'll keep it on a new line. From this x and y coordinate, from the current point to the next point, for each point in the chain. And that should give us a line when we click and drag. Oh, we have no stroke on. No stroke is causing our line to not be visible. So again, just to make sure you notice what I did there, no stroke right here was keeping our line from showing up. I'm going to remove that so we can see our line. There's our line. And now we can go back here, we can uncomment the part that was making the line move, and we should now see our line jitter and dance around a bit. And there it goes. So we have a line that jitters, we have a line that moves. Let's also put in an image, because so far we've not been using any images yet. Actually, sorry, one last thing. Let's show how you could tie together the last point to the first point. Okay, well first of all, we need to know that we have at least 2 points in order to do this. So if the size of the mouse trail is greater than 1, which means we have 2 or more, then we're basically just going to manually set those indices. Instead of get I, we're going to draw a line from 0, which is going to be always the first entry, the first point in that chain, to int last point index. How would we find this? It's going to be the size minus 1. Remember, these are 0 indexed arrays. Notice again that this is 0. And so by using the size minus 1, if there are 5 mouse trail points, those are 0, 1, 2, 3, and 4. Because there's a 0, there is no 5. And so here, instead of saying I plus 1, for endpoint, we can just say get last endpoint index. And now when I draw a line from the first point in that chain to the last point in that chain, we should just see a loop. Yep, loop is maintained. There you go. And again, if that moving around is wigging you out, we can just comment out the move point stuff, and it should still survive fine. But now we have a handy loop drawing application. And unlike previous cases where we were drawing code in a way that just stayed on the screen because we never erased it, this is being redrawn every frame thanks to this code right here, which also means we have access to those data points again, so we could use it as a trail to have an animal move along that path. We could use it as collision data to check if something is inside that hoop using certain type of mathematical routines. So there's that. But now let's go and put an image in there. So when I saved this file, by default, it went into my processing directory, which is within my documents. Well, let's go and open up that folder that we need to go to. So archives, let's see, we have documents, processing. I put the mouse point at the end to easily spot it. But here's the folder that it saves my sketch into. And you'll see, just like we expect, there's the sketch file here, and there's mouse point, our other file. We're going to create a directory in here called data. And now we just need a picture to put in there. So I'm going to pull up the internet, which could be regrettable. Cats. Seems like a safe thing to search the internet for. There's a picture of a cat. I'm going to copy that image into my cats folder, or into my data folder, cat base. I'm going to change the extension to JPG just because I know I can trust that one. And next up, what we need to do is we have to tell processing that we want a P image. We can name that whatever we want. Let's say fancy pic. In setup, we then load it by using something called, let me double make sure I'm not messed up, load image. And here we put the name of our file. So it's looking for the file that I type in here inside the data folder, which is here. And once it's been loaded, now we have the power to place it anywhere on the screen. So for example, if I want to draw it wherever the mouse is, I can simply say image, fancy pic, mouse X, mouse Y. I'm going to press play. There we go. I can still draw my lines. It draws the cat wherever my mouse goes, which is kind of nice. And of course, once we do this, so you can load any kind of image you want for backgrounds, for heads-up display information, for user interface controls, all sorts of things. And that was just a picture I grabbed off the internet. By default, processing handles a lot of different file types. It definitely supports JPEGs. It'll load a GIF, but I don't think it'll animate it. So you can use static GIFs. It can almost certainly load PNGs, I think TIFFs. Basically, if you Google processing and this image call, or P-image specifically, then you'll find out how to load these different types of images. But they're all really the same. You just do load image, and it figures out from the extension the type of image to use. Lastly, let's show how to set up a font, because that's really going to help your application look a little less ugly. Because by default, when we put text on the screen, let's put text on the screen where our mouse is too. Here are words, mouse X, mouse Y. I'm going to do mouse Y minus 20 just to give it some space above the cat. Oh, let me make sure I set this to something visible. I think fill is what text wants for the color. There it is. Yep. So this set it to a full red, 255, 0 green, 0 blue. So now the text is visible. Here are words. And there's that. But let's say, okay, so again, that's the default font. We want a nicer font. What we can do in processing is we have to go to Tools, Create Font. And now we can select from its long list. And this is, I think, actually just pulled right off of our system. Let's pick something really distinctive so we can be certain that we change the font. We can set its size here. Notice, too, that in code, there's actually ways we can change the font size in processing. I'm not 100% certain, but I would suggest that setting this size to be consistent with your font size in code is going to help it look nice. It's probably going to wind up scaling it if you do otherwise. Characters would allow us, if we want to selectively rule out certain European characters or make sure we include certain Greek characters and so on. And the file name, it tells us right here. What's going to happen is I click OK. Aha, see, it popped up in our data folder over here. And you got to know to be looking for it because it's not going to call attention to itself. When it does that, if we didn't have this folder open already from our cat face, we would just be wondering if it actually worked, but it did. Now, just like we have a P image for images, we have a P font for fonts. We'll call this nice font. And now, just like we had to load the image, we also have to load the font. Nice font equals load font. And you guessed it, just like we put the cat face there, I'm going to copy that file name here with the extension. If you don't have your extension showing your computer, as a programmer, you really should. It's going to help you out a lot. The ways for doing that vary by operating system. Google it. If you don't see the .vlw, you're missing out and just going to cause you trouble. If you don't see the .jpg, it's going to cause you trouble. You're going to need to see those extensions as a programmer. I've probably mentioned this before in other videos. I just want to stress it. Show your file extensions. Look for the way that, by default, known file extensions get hidden. Turn that junk off. You want to see them. Okay, so load font. There's the name of our file. It's going to look by default in the data folder of the same directory our sketch is in, which, as always, the sketch name of the main file has to match the folder that the whole sketch lives in. And now that we have that font, we have to set that as the font. Text font, nice font. And when I press play, there's our font. So we have drawing in a way that's keeping track of the point data so we can do dynamic things to it. Let me re-enable our dynamic things. And let's say, for example, like this move point, okay, well, maybe I don't want that random. Let's say I want it to kind of drift smoothly down diagonal. There we go. We can do that too. See, now it's just steadily adding to the x and the y values of the points that we draw. And we are displaying an image, and we're using a font. All things that are going to help make our applications look better and do more interesting, expressive things. So that's all I want to cover for now. Just going to get in there, text or point trail for our mouse, which is really helpful for drawing applications, one of the early assignments in our class. How to display an image on the screen, which is really helpful for, like I said, displaying a customized background, for showing your face in the screen, for whatever, as well as how to display text using a font besides the default sort of system, plain sans serif kind of font. Hope it's been helpful. Look for more videos coming from soon. That's Chris Delion for LMC 6310, taught by Dr. Jay Bolter at Georgia Tech in fall 2013. Thanks.